Hi friends, today we are going to study about electrophilic substitution reactions in aniline. So this is one of the chemical property of amines. So in your grade 12 chemistry there are 6 reactions to be studied under chemical reactions of amines. 5 reactions already I have given in another video. The detailed video you have to see. And this is the 6th chemical property of amine and which is only for aromatic amine, which is called electrophilic substitution reactions. And there are mainly three electrophilic substitution reactions in aniline, which are bromination, which comes under halogenation, nitration, and sulfonation. And there is one more actually, which is Friedel-Crafts reaction. I'll tell you why it is not under this. At the end of the video, I'll tell you. So we'll start with the bromination. All these three reactions by using a quick mind map I can discuss with you. So for that, I'm just drawing aniline at the center. So we are going to study about the reactions or electrophilic substitution reactions in aniline. You take aniline, add bromine. Bromine in presence of aqueous medium or bromine in water. So aniline undergoes a reaction with bromine in aqueous medium. The electrophile is bromine. This Br plus is the electrophile that is gets attached with all the three positions like 2, 4, 6. Both the ortho positions and para position. This is 2, 4, 6 tribromo aniline. Tribromo aniline. Why we are getting a tri-substituted product? Because this NH2 is highly an activating group. Activating group means a group which directs the incoming electrophile to ortho and para position. That is activating group. And this aniline is highly activating. Why? Because due to resonance, the lone pairs of nitrogen is moving towards the ring. As a result, nitrogen gives electron to the benzene. So benzene gets ortho position, both the ortho position negative and in the para position negative. It means both the ortho positions and the para positions become electron denser. So that the electrophile attacks in all the three positions equally. So because of the highly activating capacity, we are getting bromine in all the three positions or we are getting a tri-substituted product. But to get a mono-substituted product or a para-bromo product, what we need to do is, we need to do acylation. Acylation in the previous video I explained. Acylation is a reaction of an amine with acyl halide or anhydride. Here I am taking an anhydride. CH3CO twice O. I'll show you the reaction here, how the reaction is taking place is actually when you have aniline RNH2, C6H5NH2 with CH3CO twice O. That can be written as CH3CO, CH3CO, and those two are connected through an oxygen atom. So one of the bond breaks here and one hydrogen will go with this oxygen atom. So this part will be changing into CH3COOH, which is acetic acid. And the remaining product is, or remaining part of the compound is benzene with the C, like this I'll write, benzene with NH. That NH is connected with this COCH3. That is connected with the COCH3, which is an amide, which is called acetanilide. And this is the first product. But over the aromatic, if you are writing bromination and then hydrolysis, acid hydrolysis, so that this NHCOCH3 will be replaced by aniline again. Why? Because when you do hydrolysis, this part will be replaced by NH2. Detail I will tell you here bromine alone. So that bromine comes in the para position. See, you see this reaction. When aniline undergoes a reaction with acetic anhydride, we get this product, which is acetanilide. I discussed the way of reaction. After that, you do bromination. Then bromine attacks only in the para position. That is a para position. Then when you do hydrolysis, this amide group change back into aniline, NH2 group, amine group, which is 4-bromoaniline or para-bromoaniline, which is a monosubstituted product. So aniline changes to a monosubstituted product, the path is different. Don't add bromine in aqueous medium. Instead, do acylation followed by bromination and then acid hydrolysis. Got it? And why we are doing acylation, or what is the purpose of acylation? As I told you, NH2 group is highly activating group. But when you do acylation, here I'll tell you, if you are doing acylation, this is the acyl group or a amide group. So here is a nitrogen which is connected with the benzene ring. So normally nitrogen has to give the electron to the benzene ring so that the nitrogen gives electron. So benzene ring will get negative charge in all the ortho position and in the para position. That's a normal behavior due to resonance. But in this case, because of this group, which is amide group, nitrogen electron is moving away from the benzene ring. You see this? Which is away from the benzene ring. This is not taking place. Towards the benzene ring is not taking place. It's away from the benzene ring. So that the nitrogen is unable to give electron in the ortho positions and in the para position. Or that tendency will decrease. So that ortho compounds or ortho products we are not getting. Instead, we'll be getting the para products. So that part is resonance stabilized. This is the resonance structure. That is the purpose of acylation. So again, I'm moving into the route map. Here, aniline changes to 4-bromoaniline. In the previous reaction, I said it's 2,4,6-tribromoaniline. This is 4-bromo or para-bromoaniline. Now, again, aniline. Do nitration. For nitration, they use strong acid medium, which is concentrated nitric acid and concentrated sulfuric acid, H2SO4 and HNO3. And during the reaction of this, we get three products. Aniline with NO2 is electrophile in the ortho position, plus aniline NO2 as electrophile in the para position, which is para-nitroaniline, orthonitroaniline, plus one unexpected product also getting, which is meta-nitroaniline. This one also. So normally ortho and para are the expected product because due to resonance the negative charge comes in both ortho and para position. So that the electrophile attacks in ortho and para position. But why we are getting a meta product during nitration? I'll tell you the reason. The reason is when you take aniline and add acid, which is strong concentrated acids like HNO3 and H2SO4. Acid provide H+. That H+ will attack with NH2 as NH3+. So aniline will change it into NH3+. Aniline with NH3+. And that anilinium ion, this product is anilinium ion, and anilinium ion is a strong deactivating group. Deactivating means the one which directs the incoming electrophile into the meta position. So, because of aniline, we are getting ortho and para product, these two. But as aniline changes to anilinium ion, we are getting the meta product. Why anilinium ion? Because of strong acid medium, aniline changes to anilinium ion. This is a reasoning question. In presence of strong acid medium only, we are getting a para, ortho and meta product. So, that is the third reaction. But still here, you do acylation. CH3CO twice O followed by nitration like HNO3 and H2SO4 adding together and then H plus followed by hydrolysis. Then all this anilinium ion formation will be preventing, all the ortho product formation also won't be taking place. We get only para product. This time nitro group comes only in the para product. So para nitroaniline or 4-nitroaniline, it is just like our 4-bromoaniline. This is para nitro or 4-nitroaniline. So here also the reason is same only. When we do acylation, the deactivating capacity increases. Deactivating in the sense the activating power of NH2 decreases. I'll tell you in detail. See, when you do acylation first, this NH2 will changes to this part, amide. And amide is decreasing the activating capacity. Decreasing. Because of that, this when you add an acid medium, NO2 will be attacking only in the para position, not in ortho and not in meta also. And after that, when you do hydrolysis, this amide will change back it into amine. That is para-nitroaniline. Same reason, purpose of acylation is always same. Instead of moving electrons to the benzene ring, it is moving away from the benzene ring, so that the activating capacity of benzene decreases. That is the fourth reaction. So 1, 2, 3, 4 reactions are done. Now next is sulfonation. Sulfonation is by adding concentrated sulfuric acid and heating. So when you do sulfuric acid addition, SO3H is the electrophile. So that SO3H attacks only in the para position. NH2 with SO3H in the para position. And this is a sweeter ion. It forms sweeter ion. Why? Because there is SO3H. This H will be transferred from SO3H to NH2 part you will get. You will be getting the product like this. SO3 minus. Why? Because H plus is eliminated and then as NH2 changes to NH3 plus. So this is a Zwitter ion. This product is Zwitter ion. And benzene with NH2 and SO3H. This product is called a sulfanilic acid. Sulfanilic acid. So these are the main reaction. So once more we changed aniline to 2,4,6 tribromoaniline. So the important conversions I'll tell you. Aniline to 2,4,6 tribromoaniline, aniline to 4-bromoaniline, aniline to orthonitro, paranitro and metanitro together. But that question will come only like this. How do we convert aniline to paranitroaniline? Then you have to do acylation and then only nitration and then acid hydrolysis. Then aniline to sulfanilic acid by sulfonation. So that is bromination. These two are bromination. These two are nitration. And last one is sulfonation. So these are the important reaction. So in between, I have discussed about the detailed explanation of bromine, nitration, bromination, nitration, and what is the purpose of acylation, and also why we are getting metanitroaniline during nitration. Because of strong acidic medium, aniline changes to anilinium ion. So these are the conversions which we have discussed today. So you learn this electrophilic substitution reactions in this way, you will not be forgetting. It is easy to study. Thank you all. I hope you understood. Thank you.